And the last thing that we're doing in this section is going to look at all of the parent graphs of logs. So we already did all of the exponential graphs, 2 to the x, 3 to the x, 5 to the x. And we did transformations with those. We're going to do the same thing with log graphs. Now, for our very first log graph, we're going to do it in 2 steps. After this very first one, you are going to graph all of your log graphs directly. But for this first one, I'm going to first graph y equals 4 to the x, because we know how to graph that from before. Since it's an exponential graph, it goes through the point 0, 1, and if you plugged in 1, you get 1, 4, and all exponential graphs have an asymptote at y equals 0. So here's the shape of a parent graph exponential graph. Now when we graph a log base 4 of x, that's going to be the inverse of an exponential graph. And if we think back to our first unit, how do we graph inverses? That's a reflection over the diagonal line y equals x. Graphically, what happens? Every x and y coordinate gets switched. Every x becomes a y, every y becomes an x. So if I want to graph log base 4 of x, I'm going to have 1, 0 instead of 0, 1. And instead of 1, 4, I'm going to have 4, 1. And instead of an asymptote at y equals 0, the x and y switch there as well, we have x equals 0. And then in part B it says, identify the intercepts. We have an x-intercept at 1, 0, and there are no y-intercepts. We have an asymptote at x equals 0. The domain is x is bigger than 0, and the range is everything. So for this very first log graph, I drew the exponential graph and switched the x and the y's. But now, what I expect from you is if you have a log graph, the very basic log graph, you should be able to do directly. So if I asked you, we're going to do a couple more. If I asked you to graph y equals log base 2 of x, you would do this directly, and you would say every log graph has 1, 0, and if the base is 2, I'm going to have 2, 1. And every log graph has an asymptote at x equals 0. There is the shape of my log graph. So you don't need to first graph the exponential graph to graph the log graph. I'd like you to be able to graph it directly. Because our next thing that we're going to be doing after your test in the next couple days is we're going to be like, oh, can you graph y equals 3 log base 2 of x minus 5 bracket plus 1 and do all the transformations? And the answer will be yes, because you know how to do transformations already. You could do all the transformations with any log graph. Oh, we're going to do one more. Check this one out. Since you learned a new number the other day, we may as well use it. Let's graph log base e of x. It's not hard. All log graphs have, even if it's a base e, all log graphs will have the point 1, 0. All log graphs will have an asymptote at x equals 0. And since the base is e, you'll have the point e, comma 1. And the shape looks like the other log graphs. Now the number e is so special that in logarithms, they gave this graph its own name, ln of x. The e, right? So in logs, you have to write a base. Except it's 10, you don't have to write it. And if it's e, you can write ln instead of writing log base e. And the reason for that is it happens so much in calculus that this is so much faster to write because you like save 2 letters, right? Most of you are probably wishing when you write your name, I wish my parents gave me a smaller name, right? Take off 2 letters. You just see a decimal. Your signature would be so quick, done, right? So much time you'd save if you take away 2 letters from your name. Yeah, now everybody's deciding with the longer names what 2 letters would I take away. Would it be an E, but I just go like N, what would I go by? So, yeah, this, and the reason it's ln is this is called the natural logarithm. Of course, it's French, so it's like logarithm naturel, or something like that. That's why the L is first and the N is second. If it was English, it would be NLX, but no, it's lnx for the natural logarithm. So when you have a natural logarithm, it's like log base e. And you write it that way, but graphing it would be exactly the same as graphing everything else. So, questions for practice on this one, part 10 and 11.